Greetings, programs. Hope everybody's doing well. I know I'm doing pretty good today. It's been a while since I've made some educational type videos for my YouTube channel. Been conversing with some friends, and they're talking about a bunch of settings. And how do you know the settings are right, that sort of thing. So I decided to make this video of what I do every time I have a new filament style. In this case, this is PLA Plus brown. I have printed with PLA Plus in the past, so I've already got those settings kind of dialed in, but I've got a generic setting on my printer at the moment. I have PLA Plus brown. I've got a spool I need to take off my printer and a new project to do for somebody else that's going to require this brown color. This had a brand new spool, that sort of thing. We're just going to make a video of it. I'll cut it all down and do some speed up, that sort of thing, and to show you my full process of what I do and make sure I have the settings right to begin printing. I still may have to tweak them after I get these settings done, but at least you'll have a good start on anything you got going on. So to let you know exactly the filament we'll be using today, let me do a little close-up. This is PLA Plus. It's brown, 1.75 millimeter. It says the print temp goes from 205 to 225. You can get the skew and all that kind of stuff off of it. Also, there's a barcode for you. Yes, this is the Inland brand. I get this from my local Micro Center, and I'm really sorry if you don't have a Micro Center close, but you can order this online. And I think the formulation for most PLA Pluses will be somewhat similar, but it doesn't really matter what the formulation is. The process is still the same. First of all, I've got to take the filament out of my printer now. That's currently on there. So let's go do a couple things. One, we need to heat up the nozzle so that we can get the filament out. I have an Ender 3 V2, but in this case it doesn't really matter. What you need to do is just see changing the filaments, changing the filament. So temperature, I'm going to set my hot end to, in this case, 210 degrees Celsius. Allowing it to go. I am using, I'm going to give you my settings here, but this is, and once that comes up, the temperature, we'll take some stuff out. So I'm going to step back. Okay, I see we're up to temperature now. What I'm going to do is switch over here. You see the filament I have here on here, I need to take it off. So since I'm at temperature, what I'm going to do is I'm going to make it where I can push in the filament just slightly and pull it out pretty quickly. Sometimes it gets a bit of an end on it. I'll show you. See if I can show you real close. See, that's a little fatter on the end. Sometimes that gets stuck. It doesn't want to come out. So now we can get that off. Enough out of this. We go over to, you see the filament's already started coming out, and if I manually turn it, it'll come out some more. That's exactly what you want. You want a nice straight filament. Even though this has come out and it's pretty clean, one of the things I do to make sure I got a nice clean filament run out is have the extruder manually extrude, because I want a good amount of extruding, and I want the extruder to extrude it. So that's going to push it like it's pushing as you're printing. In fact, what I can do, since I got enough of that already, I can grab some of that. Oh, so okay, so this is the filament that came out. Now this, I've got a 0.4 nozzle, and we're going to see what actually came out of that nozzle. Now, because we're not pushing things down and we're not putting on a print, doing all those sorts of things, this is not going to be the best gauge of what's actually coming out of our 0.4 nozzle, but it gives us a starting point. I have my caliper here. If you don't have a caliper, it's a must. You get a caliper. So if we look at that, that's actually pretty miraculous. we have a 0.4 coming out of a 0.4. That's really, really good. Most of the time, I've seen that as low as 0.31 and as high as 0.67. Crazy, right? The different materials do different things. And I will tell you, in the materials getting better and better about being the same diameter as the hole that's getting squirted out of it. It's not always the same, but you need to make sure it is. So in this case, we can use our 0.4. We can use straight up everything we're going to do, and we're going to do a test print. Okay, I am using Cura 5.1. I'm a little bit behind, but it still does not matter in this particular instance. But I'm taking advantage of the marketplace for Cura, and one of those things is a extension that says parts for calibration. Now, if you've never seen the parts for calibration, you can go to the marketplace, dial it up. You got all these parts. You know, where do you find a cube? Do I need to make my own cube? Do I need to make all these other things that I want to make for calibration? Do I need to make a sphere? Do I want to make a retract test, an acceleration tower, all those sorts of things? And I don't even know what a flow test is. And we're going to make ourselves a cube using the parts for configuration extension. Cube, right there. Hard to see because it is indeed white, because that's where I've got it set up. Turn it just to slightly. And if we go in our preview right now, we're going to make some changes on this because we don't know if our 0.4 is right and all those other sorts of things. Let's go up and make sure that all our settings are correct. Infill density, see where it says 20%, those kind of things. So if we were to go down in this, you'd see the infill, right? See the infill as it goes in. But that just gets in our way for what we want to do. Our flow is at 100 because that's the way we're going to start all this. So we have a nice, even, easy number to figure things out. Because I don't know how that block is going to go, and I could have things all kind of crazy ways, and it might not make a good stick on the bed. And just what I've been doing normally is I change that to brim. So we're going to get a nice hard seal. It also allows me to check for height here and see if we got a nice level across the bed. So all of this should be smushed together and be like one solid piece when it comes off. If it's stringy, you're not, one or two things, not close enough to the bed, and or your line width is not right, not correct. Your line width and your slicer there a little bit. Or so you could, there's another thing in Cura, you can change the flow on the initial skirt brim flow. You can and you have an initial layer flow. You can bump that up slightly if you wish, if you need to. Special modes. Prusa, I figure what Prusa calls it, but Cura calls it spiralized outer contours. So what's going to happen is there will not be a level retraction at all. The entire time this thing will be spiraling up after the initial bottom couple of layers. So that you can see part of that, then we can run down through it. And now, since I've done that initial spiral layer, you notice there's no top, there's no infill. If we look down through it, all that we have is the bottom. So we know this should be 20 by 20 by 20, and it should be, then we can measure the walls on all four sides, which is how we get our real line width of how we're really printing. So I'm going to save this to disk, upload. It's now uploaded. Hit the print button. Realign my camera slightly, and we're going to let this run. And I'm going to mute the mic, and when we'll go ahead and do this video, and I'll speed it up or do something else as we get going along, and the programs can watch the whole thing. Yay! It finished finally. Had to restart that in the middle of their programs. You might have noticed that, you might have not. Let's see what we got. I'm going to get my spatula and take it off. That's on there pretty good. Okay, let's see what we have here. turning on point. From 0. Going to check our brim. 0.2. Exactly what we expected. Let's go around a couple times just to make sure. 0.201. That's still pretty good. 0.22. It's just on the thing there. I did affect that a little bit. That's prying it up. Still at 0.2. That means our leveling is actually doing pretty good. And just for grins, all the way around, 0.2 works. Now let's check our walls. You can see, if you'll look, there is no, it's kind of hard to see, but there was no traction, no layer lines. It's nice and smooth. And I forget which way, it was like that on the print bed. I'm looking at that part right there was torn up. We're still at, so I push down on it. Then I got a 0.5 out of a 0.4 nozzle. Let's go write these down. .5 of a 0.4 nozzle on one side. 0.5. Next one. 0.48. Next one. 0.48. Ah, 0.47. And pull down my favorite calculator in the entire world. 0.5 plus 0.48 plus 0.48 plus 0.47. It's 1.93. Divide that by 4. A little division there by 4. Old school. Do my math. .4825 is the average. Now, that's probably good enough for what I call government work, for most of what people want. And in fact, when we're measuring things, let's go ahead and look on my dimensional accuracy here. A little bit less on that, 19.88, 19.85. So why don't we try to do that, right? If we're two 2/1000ths off there, right? On two sides. So that's at least a 0.5 millimeter off. Or no, 5/1000ths off on it. So if we're looking at our thing here, that plus 5/1000ths gets us in about as close as, well, you can get it closer, but really close for government work. So let's see if we want to do that at 0.5. What would we do? Well, here's what you do. What we want is 0.5. That'd be our average, right? We got 0.4825. If we do that ratio, let's see what I'm going to do here. I'm going to do a 1 over times, math is easy here, and that's a 1.036. If we want to go crazy, 1.036 on there. And so because of our math, we started with 100% flow. So if I wanted to get this as 0.5, because we're going to try this again. So my flow should be 1.04. Sorry. 104.00 for my flow. Let's go change that. Reprint this thing. See if it helps. All right. And here we can just say look for flow. And when we're looking for this outer wall flow, top floor, top surface infill material, we want initial layer flow, which look at our initial layer. You look at the initial layer right there. I mean, you can't really pull this apart, which is exactly what you want. So I think we got a decent initial layer floor. There's a little bit on the outside when it's just getting started, but once we get going, I think it's good. And because the just getting starting part is sometimes a bit crazy, but we're good. And then once it gets that, we start ripping away and tearing at it, and it just tears away what it gets supposed to tear away, because it's brim. That's his job. All right, wall flow is up here. We want to change this to 0, and then that will change all the way down. Look at our bottom, right fast. Change it to 104, you see it changed all the way down. Look at the bottom right fast. Our bottom does look good. There's nothing missing, no holes. It's nice and lined up. We're not bulging anywhere. If I put a heavy duty light on it, now that really messes up your video. The flashlight's actually an LED light. The LED light is not a constant on thing, so flashing on and off. Our eyeballs think it's on though. Okay, we've done all that. Sorry you missed that. Save the disk. Yes, I'm going to overwrite my file. And then we're going to go back to the printable files list because I don't trust this. I want to say delete that. We're going to re-upload it. Okay, programs, we did finish that up, and let me take that off. Got a little weird. It's a little weird. We didn't get a full brim for some reason. I don't really know why, but that's not what we were checking. So let's go through this thing again. Turn it on, make sure we're zeroed out. Do one side. I got that at 0.5. Oh, that 0.515. Alright. Turn the quarter turn. Oh, look at that. 0.49. Quarter turn. Wow, let's look at that. That's crazy. 0.51. One more quarter turn. We got a 0.48. And that's a calculator here. 0.515 plus 0.49 plus 0.51 plus 0.48. We get 1.995 divided by 4. 1.995 divided by 4 equals, we have, I'm going to write the full number out. 49875. And if we round what we care about, any one of those numbers, That gets us a 0. We're not doing 2 digits, so if I round up the 3rd digit, that gets us a 10, and the 1 that gets us to a 0.5 average. It's to a 0.5 average, and I think at this time, programs, we're ready to go make some prints with a 0.5 nozzle width. What do you think about them apples? So, okay, programs, I hope you learned something today. I know that I had some more clarity, so I actually learned something today. And if this helped you at all, please leave me a comment. If you've seen me do something wrong, or you know a better way to do it, please leave me a comment. And if you liked it, great. If you didn't like it, that's okay too. But if you didn't like it, I would really like to know why you didn't like it. So leave me a comment on why you didn't like it, so I can get better and we can all learn something. And that kind of thing. Anyway, whether it's from my mistakes or your successes, hope you learned something today. I know I did. Programs, be well, and I'll see you around. Take care.